Okay, in this topic we'll be finding the greatest common factor of a list of items, or in this case numbers or terms. Recall in the previous topics that we have done when we multiply with the distributive property to multiply monomials and a binomial. For example, if we had 4y and let's say 3y plus 5, that gave us 4y times 3y plus 4y times 5. At the end it gave us answer of 12y squared plus 20y. Okay, in this section of our topic here we will reverse the operation going from here to here. Operation of multiplication given a polynomial such as this one here, we will ask you what factors are multiplied to obtain 12y squared. So remember how we can get 12y squared and 20y. The process of finding the factors of a known product is called factoring. So going from here to that, we're going to be factoring. Okay, so let me write that down. Multiplication. Okay, let me zoom in there so you can see much bigger. As I write some more, I might have to zoom down a little bit. Okay, multiplication given the factors, we find the polynomial, we find the polynomial. Okay, so let's say we have now 4y 3y plus 5, that would give us 12y squared plus 20y. 4 times 3, 12, y times y squared. Okay, now given a polynomial we find the factors. So remember, this is multiplication. Given the factors we find the polynomial. So this is what we did. Now we're going to go factoring. In factoring, let's say given a polynomial we find the factors. So that's what we are going to do. So we are given this polynomial now, and we will find the factors that got us to this. To factor a polynomial, okay, so let me tell you what that factoring means. To factor a polynomial, what does that mean? It means to express it as a product of two or more polynomials. That's what it means. The first step in doing so will be when factoring a polynomial is to determine whether its terms have any common factors. So that's what it means. Factoring. Okay, when we are factoring, given a polynomial, as in this one here, we will find the factors. Okay, to factor a polynomial, to factor this out, it means to express it as a product of two or more polynomials. The first step when factoring a polynomial is to determine whether its terms have any common factors. Okay, so we're going now into finding the greatest common factor of a list of items. So, to determine two or more integers have common factors, it is helpful to write them as a product of prime numbers. What does that mean? So to determine, right, so consider I give you two numbers. I give a number 90 and I give a number 42. And I ask you um, to find me the greatest common factor of 90 and 42. So let me write it here. What are the greatest common factor of 90 and 42? What you are going to do, you're going to find me the factors, the prime factorizations of 90 and 42 given there. Now, how are you going to do that? I could ask you to give me the numbers and you should be able to do it, but that would not be fair, so therefore I'm going to show you how you get those numbers there. Consider 90. You take the number 90 here and start dividing by the first prime number. Well, obviously you will need to know what's a prime number, okay? So the first prime number will be 2. Let's try to start with the number 2. 90 divided by 2 will give us 45. 45 cannot be divided by 2 again because it will not give us an even value. So I am a evenly divided value. So now we go to the second prime number, which is 3. 45 divided by 3 will give us 15. 15 is divisible by 3, so we divide by 3 there and we get 5. 3 can no longer be divided into 5, so therefore we will divide here by 5 to get us 1. So notice what I did. I said 90 divided by 2, 45. 45 divided by 3, 15. 15 divided by 3, 5. 5 divided by 5, 1. Therefore, the prime factorizations of 90 will be 2, 3, 3, 5. So we put 2 times 3 times 3 times 5. So if you're thinking and if you got this concept, you should know what is 42 now. We'll do the same thing with 42. You divide there by 2. The first prime number, if you can go in there, you get 21. 2 cannot go, so we go 3, 7, and then 7. That gives us 1. So therefore, we have that 42 is actually 2 times 3 times 7. Okay? So these are the prime factorizations of the respective numbers. Now, so it said now, so then, if you notice here, both of them have common terms. Here we have a 2, here we have a 2, here we have a 3, here we have a 3. This 3 is not the same 3. We will only join a common value that is with both of them, okay? But it cannot be repeated. In this case, well, this cannot be repeated for this one here. You don't use this one. And this 7 cannot be going there, nor this 5 can come here. So now, what do we notice? That 2 and 3, there's a 1 prime factor of 2 and 1 prime factor of 3 in common. So let me write it here. Prime factors in common are 2 and 3. Okay, now we can conclude now. So conclusion is this, that 2 times 3 will give us 6, and 6 now is the largest natural number that divides for 90 and 42 exactly. And we say that 6 is the greatest common factor, or GCF. So instead of you writing greatest common factor over and over, let's just write GCF. Once you see GCF, it means greatest common factor. Okay, so let me give you a next one. So what is the greatest common factor by definition? So Here it goes. The greatest common factor of a list of integers, okay, is the largest common factor of those integers. Okay, so that's what it means. So let's go over this because this is very fundamental and we need to know this before we deal with factorization in much more detail. If I give you two numbers, three numbers, four numbers, five numbers, whatever amount of numbers, and I ask you to find the greatest common factor, you can break them down this way. Take each number individually and start dividing by prime numbers. Now remember, prime numbers. So we're going to be using the first prime number. If you can divide evenly, you continue. And then now, not because this one here was only divisible by 2 once, it means you will always divide by 2. No, it doesn't mean that. It simply means that this first number was only divisible by 2 once. If you notice 3 was divisible twice, sometimes they may be divisible 4, 5, 6, 7, 8. It doesn't make any difference so long as they can divide them evenly. Okay, you would not use here divide this by 6. It will not work that way. 6 is not a prime number, right? So let's work some examples. Here we go. And the rule, the directions that I'm going to give you is to find the greatest common factor of the list of numbers. So then, let me give you one. We have 45, 60, and 75. We'll find the greatest common factor of those terms. Okay, do we have a strategy? Yes, we will use prime factor each number in the list. Then we will identify the common prime factors and find their product. That is what we did just a while ago. We found the prime factors and then we found the product of the ones which are common. So we're going to be doing that now with a set of numbers, with any number that appears from now on. So let's start. This is the ladder method that we're going to be using here. Not necessarily you have to be using this method, you can use other methods. Start dividing by 2. This can go divided by 2 evenly. So let me zoom in there a little bit more. So we have 45 divided by 2 by 3, yes, we get here 15. Then by 3 again, 5. Then by 5 here, 1. So therefore 45 is actually 3 times 3 times 5. Okay, and then we go with 60. Start dividing 60 by 2. You get there 30, 2, 15, 3, 5, 5, 1. So therefore 60 is actually 2 times 2 times 3 times 5. Okay, then we go with 75. Factors of 75, we start dividing by 2, can't, so we go to 3. 3 here we get 2, 5, then 5, 5, 5 again, 1. So therefore, we can say that the prime factors of 75 will be 3 times 5 times 5. So let's look at them. What do they all have in common? Okay, so we look at the trees. 3 is here, 3 is here, and 3 is here, so that's a common factor. This 3 is only here but not in the other one, so we cannot include that. 5s, yes, 5s are here, so therefore the 2's will not be included as part of as the greatest common factor value. So what we do now is that we are going to take now and we're going to say 3 times 5, and that gives us 15. Therefore 15 is the greatest common factor. Okay, so notice what we did. I gave you three numbers and you are to find me the greatest common factor of those three numbers. You're going to use the ladder method if you want individual numbers and start to divide them by the first prime number that can go into them evenly. Then you're going to put them this way and then see which one is common with all of them. Okay, let's try a next set of numbers. I give you 16, 28, and 35. So let's break them down into their common factors. The prime factorizations, we have 16 here, divided by 2, that gives us 8, divided by 2, that gives us 4, divided by 2, that gives us 2, divided here by 2, we get 1. So notice that 16 is actually 2 times 2 times 2 times 2. Okay? And then we have 28. Divide 28 by 2's. You get here 14, 2, 7, and then 7 here, 1. So therefore 28 is actually 2 times 2 times 7. Okay? Then we go to 35. 2 cannot go into 35, now 3 cannot go into 35. We try 5 now, that gives us 7, and then 7 here gives us 1. So therefore 35 has the prime factors of 5 times 3 times 7. Okay, so what is common in all of them? Here we have 2, 2, 2, 2, 2. Okay, so if you notice, the 2's are not common in all of them, the 5's are not common in all of them, the 7's are not common in all of them. So there are no prime factors common to 16, 28, and 35, and it will happen this way. But their greatest common factor exists. There's a number that can go into 16, 28, and 35, which it does to a many number. And therefore, we can say that in this case, our greatest common factor is 1. So if you encounter a problem like this, where no number is common in all of them, then the greatest common factor is simply 1. All right? So, now, a small tip to this is that the exponent of any factor in GCF is the smallest exponent that appears on dot factors in all of the numbers under consideration. We can use this as 3 squared times 5, 2 squared times 3 times 5, and so forth. We can use all of those concepts there and we will still get our answer. So let's go with a strategy to finding the greatest common factor. First thing, our strategy for greatest common factor. Write each coefficient as a product of prime factors, and that's what we did. This simply means you put them this way as a product. Okay. 2, identify the numerical and variable factors common to each item, and 3, multiply the common numerical and variable factors identified in step 2. This is the step 2. Okay, to obtain the greatest common factor if, and this is very important, if there are no common factors, then the GCF must equal to 1. Okay, so that's the strategy. So let's go with some few more examples. All right, and here is where it starts to get a little bit more complicated, because we will not just be working with numbers, we'll be working with variables. Nevertheless, don't worry about it, we'll be working with that. Okay, so let's start here. Okay, I'm gonna start, and I tell you now, find the greatest common factor of each of each of terms, and I tell you that this is 33c and 22c to the fourth. Don't get frightened, this is not COVID-19, this is just simply maths. We'll make math very simple. So how do we do that? Again, you work out the same way. Remember, we did the ladder method for get the numbers, so let's do them piece by piece. So we put here 33. 33 is only divisible by 3, we get here 11, and so 11 here goes 1. So therefore we can say that 33c is actually 3 times 11 times 1c. There's one single c, a power of 1, so put times c. You have just factored it out, the prime factorization. You come to 22 to c to the fourth. Start dividing here by 2, you get here 11, divide here by 11, you get 1. So therefore 22c must be equal to 2 times 11 times, but that's c to the fourth. So now we're going to put c to the fourth here, and so you must multiply that c 4 times. Now that is c to the fourth. So what's common there? Well, what's common is that we have an 11, we have a single c. Therefore, our GCF is 11 times c, or simply 11c. Notice what we did here. Find the greatest common factor of these terms. We took 33 and broke down 33 to its prime factorization, and we look at the letters, variables, and we multiply the total. With 22, c to the fourth, we do the same thing. 2 times 11, that's 22. C times c times c times c, and that gave us c to the fourth. So we look at what's common, 11 and a single c. So this must be the greatest common factor. Okay, let's go for our next one. We now have, say, b, and I give you 42 s to the third power, t to the second power, 63 s to the second power, t to the fourth power, and 21 s to the third power, t to the third power. Now don't worry again, let's take this very easy. This is simply maths. We will work them piece by piece. So I'm going to work it right down here so that we can show you all of the steps. If I'm working on this side, it might be too squingy. So we're going to work it here and then put the breakdown below after we finish. Okay, so let's start with 42. When I take 42, okay, I think it will fit here. So let's take 42. If I take 42 now, I said 2, 21, 3 into 21, that gives us 7, then here's 7, 1. So I can say now that 42, right from here, 42 is third t squared equals 2 times 3 times 7. There's a single s, there are 3 s's, so we put times s times s times s. How many t's? There are 4 t's times t times t. Notice what I did. I just expanded the base on the powers that amount of times. So I go to 63 now. Divide here by 2, can't. By 3, yes. 2 and 1, 3, 7, 7 here, 1. So therefore I can say that 63 a squared t to the 4th is actually 3 times 3 times 7 times how many s's? There are s squared, so we put s times t to the 4th, t times t times t times t. Okay, that amount of t's you will put here depending on what's the power. So now we go to 21. 2 cannot go into 21, so you try 3, yes. 7 here, 1. So therefore 21 is third. The third is actually 3 times 7 times s times s times s. How many t's? 3. So you put t times t times t. Okay, so we have gotten the prime factorization along with this variable for these terms here. Now let's see what do they have in common. You look at numbers first of all. Do they all have in common number 2? No. They all have in common number 3. Okay. Do they all have in common the number 7? Yes, all of them have a common 7. Okay. How many s's are common in all of them? If you notice, there's 1, 1, 1. Next one, 1, 1. No more s's common in all of them, so we cannot mark no more s's. T is now 1t, 1t, 1t. 1 next t, t, t. Therefore, we can say that the GCF is actually 3 times 7 times s times s times t times t. Okay, so that's our value for that one there. Okay, so we multiply that out, and now we combine it to get 3 times 7, that gives us 21. S times s will give us a squared, and t will be t times t, t squared. Okay, so that's our greatest common factor for these 3 terms here. All right, so this should not be difficult for us to be working out. So this is finding the greatest common factor of a list of items, which we just did.